Good evening, guys. This is Lanika Green, and I am going to show you guys a quick screencast of my favorite algebraic lesson, which is the Pythagorean theorem. Because I like math and I really love this actual objective, I decided to do my screencast on this particular lesson. So before we get started and I show you guys the actual lesson, let me go ahead and give you guys a brief synopsis of what the Pythagorean theorem is. It's basically saying the sum of both legs, which are A and B, are equal to the hypothesis, which is C, and this is a right triangle. So before we get started, just to kind of show you guys the program that I'm actually using, which is Paint 3D, which is really easy that you can use in a classroom. Here you have different options that you can use, different types of brushes that you can actually use. You also can input 3D shapes, good for math, 2D shapes, excuse me, or 3D shapes. If you want to get a little festive when you're doing a particular lesson, there are certain stickers that you can actually use. You can use text also. Myself, I find it easier to use text when doing the 3D paint. It comes out, of course, more clear, and I'll show you guys an example, but it's actually up to you all. And when using text, you can use different fonts, and you can use different font sizes, bold, italicized, or underline them, and you can also choose which alignment that you would like to use, whether left, center, or the right alignment. So to give you guys a quick example, we will do one problem and I'll show you guys how I actually worked the 3D paint. Now this was already done just for the sake of time so that I can go ahead and have it here, but I'm going to actually do an actual example of the Pythagorean theorem. So first of all, I'm going to create a right triangle for my example. So I would actually click on the shapes and over to the right, you would actually see a right triangle. Now, when you first put the triangle here on your page, it's going to come up big, but the good thing about it is that you can actually adjust your angle, right triangle, excuse me, for the size that you would actually like for your problem, which I actually just did here. Now, in order for me to go ahead and add my sides, instead of putting A, B, and C, I am actually going to put numbers. Again, I'm going to show you the example with doing it with the brush and the text. So with the brush, I can write like the number 6 here, and I can write a 8, and I can do X because this is what we're going to be solving for. You see how that actually looks? I really don't like the way it looks, so I'm just going to go here quickly and undo what I just did. And I'm actually going to change it into the text mode. So once I click on text, you'll just click how the text you would like it to be. Click here, you could put the number 6, text again, click the number 8. And then lastly, because we're trying to actually find the hypotenuse, it's going to be X. And there we have it. So now over in this area here, again, this is where I'm going to actually solve the problems with the students, which would be really easy. Again, starting with text. And again, it's up to you all if you like to use the brushes. I just don't, I know that you can change the thickness and everything for the clarity of it, but I just find it easier for me to type in everything as I'm going and going to create a lesson. Now, before I go forward, I wanted to show you all the formula that is used for creating solving a problem using the Pythagorean theorem. It's a squared plus b squared plus c squared. Usually when students see it, they can see it in another formula, but this is, written in a standard form, which is you would actually see the square root is actually smaller up here. But some students here, especially when you're putting it in calculators to solve the problem, they use the little the little tilde here, the little apostrophe like letter. So it's a squared plus b squared equals c squared, or sometimes they write it using the parentheses. So I'm going to use it here like this second method. So again, just using it to text, excuse me, to type it would be a little bit quicker. So again, I'm going to go with my text and we're going to start our problem here. So if we're looking at our problem, we see 6 is represented by A. So we want to do A squared plus B squared equals C squared. So looking at the problem, we see first A is the number 6. So we would have 6 squared plus B squared, which is B here, and 8 is represented by B. So B squared equals X, which would represent C, X squared. Now, when solving the problem, we're going, and I'm sorry, you can adjust the size too so that you can kind of see it bigger if you need to in the class, and I'll go and show you how to do that as well here at the top once we're done. So we're going to go ahead and solve for 6 squared, 8 squared, and x squared. So when we say in 6 squared is 6 times 6, which is 36, plus, excuse me, 8 squared, which is 8 times 8, which is 64. And then we would put the equal sign, which is x squared, which is what we're trying to solve for. Next, we are going to add our numbers together. 64 plus 36. And we're going to put the sum of both of those numbers here at the bottom. 64 plus 36 equals 100. And 100 is going to be equal to the x squared. Now, when we're looking at the problem, we're looking at the students and we're trying to figure out how are we going to figure out the square root of x squared. What is x squared? So basically when we're teaching the students, we have to square root both problems. Square root of 100 and the square root of x. So when we're doing that, we know that the square root of 100 is equal to 10, which means 10 times 10 equals 100. And the square root of x is x because x times x is x. So our problem is going to be solved. Excuse me. X is going to be 10. I like to tell my students to check their work because, of course, anybody can just put down an answer. So if you wanted to check your work or have your students to check their work, the same thing you would do here at the bottom. You would just add where the X is. Excuse me, let me go back. Where the X is here, you can just put a number 10 and let's see if our problem is actually correct. We're going to click back on the text and we're going to check our problem. So if a squared plus b squared equals c squared, then when we put in the numbers where they're located, then it should be correct. So 6 squared plus 8 squared should equal 10 squared. So 6 squared, again, 6 times 6 is 36, plus 8 squared, which is 64, equals 10 squared, which is 100. 36 plus 64 is equal 100, and 100 is equal to 100. So that means that we actually got our problem right. So to make the screen bigger, because if you see here, you see that the 100 is kind of like short here at the bottom, we can actually make our screen bigger, magnify our screen a little bit bigger. So what we would either do here is magnify the screen, excuse me, so that the students will be, you will be able to see it here. Also, you can click here on Canvas, and then you can actually make your screen bigger here as well, so that you will be able to see your actual footage here that you actually have on your screen so that the students will be able to see it. Now, this is something that will not necessarily take a lot of time to do, but once you actually get used to everything that you're actually doing, then you will be able to move faster and maneuver through it. As I stated, it could be easier to use the brushes, or you will be able to go ahead and use text. I like text, and it looks a lot neater to me when you're doing text, especially when you're doing mathematical problems, as far as algebraic problems as well. But I hope that you guys enjoyed the screencast. And if you have any questions, feel free. And thank you all for watching.